In the next three examples, we'll make use of some algebraic properties of log functions to rewrite the given expression so that we can apply the rules that we've established so far. In example 17, we're going to use the algebra property that the log, in this case the natural log, of x to the a power is the same thing as a times the natural log of x. That's a property of logs that was covered in college algebra. We can bring that exponent down as a factor in front, which, now that we've introduced the power rule, looks a little bit like that, but this is different. This is an algebraic property of log functions. We haven't done any calculus yet. And what that lets us do is rewrite this function as -3 times the natural log of x. That means we can find d over dx of r of x by setting aside that -3, which is just a coefficient, and taking the derivative of the natural log of x to get -3 over x. In example 18, we're taking the natural log of 5 times x. The log property that we'll want to call on here is that when we have the log of two factors, two values being multiplied together, we can break that up as the natural log of a plus the natural log of b. Meaning we can rewrite this with those algebra properties as the natural log of 5 plus the natural log of x. And when we find k prime, then we'll differentiate term by term. The natural log of 5 is just a number. You could plug that into a calculator to check, but there's no variable component there. So this is just a number. That's going to go to 0. Plus the derivative of the natural log of x, which is 1 over x. So our derivative function in this case is 1 over x. In example 19, we'll call on a similar-ish rule to what we just used in example 18. In this case, we have the quotient of two values inside a natural log. We can break that up as the natural log of a minus the natural log of b, meaning we can rewrite this problem as the natural log of 9 minus the natural log of x. And when we find f prime of x, we'll differentiate term by term. The natural log of 9 is just a number, so that derivative becomes 0 minus 1 over x, or -1 over x.